my job here is supposed to wake everyone up. Doug told me that before I came here, and so I'm supposed to do a lot more physical action. So you guys can kind of see some of a product we brought with us, all made from recycled polymer, all from post-consumer waste stream. As you can see, this is one of our earlier famous product, not product, let's say, because product means you actually produce them and still mass producing them and selling them. This is actually made from 100% recycled PET. This is HDPE, and this is PC. Okay, so and they're all designed to be 100% mechanically separated, and so when the building can be totally recycled. If you actually see the structure, is no glue, so it can be easily recycled. They are all mechanically interlocked, so they can create a very strong bond. And so we actually built a bridge in order for us to convince the government that a building like this actually can exist. Is actually we asked the mayor to go on the bridge that we built with only recycled material. We asked him to jump on it to pretend it's the typhoon coming. Okay, and then because we need to design with 500 pa, which is 5,000 pa, 5,000 kg per square meter of forces for hurricane forces. So another product, another system we recently built is a shelving system. It's also made from recycled PC. Okay, so there's a lot of the PC expert here. And then we work with aluminum that we recycle also from a Coke can. And so we create these shelving system for interiors, for exteriors. This is for exterior. And then we have, this is a PC panel. Recently, we are going through multi-layer extrusion to create different type of hardness for the fold and different type of performance for different type of scratching capabilities for, imagine like suitcases. For building material, we had to turn this into a sound board so you can actually reflect the sound for like spaces like this, and also translucent and fireproof. So as you can see, we are application-based type of company that we take recycled material, we re-engineer it into a product that can be displayed in an architecture scale. Okay, and of course we do have very like gimmicky products. Those are completely gimmicky. Like I have a lot of those gimmicky products myself, including my underwear and my performance underwear here. It's all 100% recycled PET with bioethanol. You know, so, and we're making a bioethanol plant with. So we package stuff. That's basically what we do. We package recycled material for designer, for innovators, and for governments. Okay, and big enterprises. So we work with Taipei government a lot. PDIC is one of our earliest partner when we first started around 10 years ago. But of course, we start working with them like recently. Within the last couple of years, we do a lot post-consumer certification with them. We do testing with them. We lecture with PDIC to educate the industry a lot. So we, in general, we are definitely, I think, we are the applicator of a lot of the technology. I want to also introduce two other people also from my office. One is Chris. He's our chief material scientist. Okay. A lot of our work, in order to be possible, we have to have a very cross-disciplinary team. In order to have a cross-disciplinary team to affect the system, you have to have a chemical. I myself is a structural engineer and an architect. And there's Johan. Johan's he's our sustainable director who's responsible for a lot of the testings, all that stuff with communicating with the sustainable industry and all the certification process. So we do LC analysis with Harvard. We came out with the LC analysis for building material. So how much carbon footprint is this material relative to what you buy from IKEA? This is something consumer needs to know. And how do you calculate that? How much water do you use? How much water did you waste? Et cetera, et cetera, et cetera. I think a lot of this information, I think we'll quickly go through in the deck that I prepare. The deck is really quick. It's mostly image-based, so we can quickly go through some of the idea that we have. Here's a clicker. I guess when we start a company, you have to have a model. So and you normally have to put that model on the T-shirt. So the first movie that influences us a lot is that movie called Zoolander. I don't know if you guys remember. It has a brand called the Dare Leak. Okay, the Dare Leak is basically all the fashion products made from trash. So it was like, oh, okay. So that's what inspired. Like that's like a post-rationalization, obviously, but it's from that movie, okay? And so we want to come out with a separate one. So we came out with this thing that's very good for clubbing. It's called 0% Virgin. So our staff always wear that when we go to the club. And on the back, it says 100% trash, okay? And that is another very simple model that how we communicate is what we're trying to do. And these are some of the building that we built, and this is the one that's most published by National Geographic in the mega structure. It's a Taipei Expo Flora Expo using 100% recycled PET. We recycle 1.5 million PET bottles from consumer within 9 days. Really, like it was completely just ridiculous. Everyone just bring in their daily trash, and we created this building. And this is a public awareness with the city government. We work with the mayor. We work with the biggest PET supplier in the world, which is Far Eastern Group, which I'm sure you guys will hear a lot from it. And but most of these things that we do, and with the Taipei government, the good work that they do, are embedded. No one really know about it. So we basically repackaging that and let everyone know what we're doing. So you can see the interior is insulated. You can see it has a 30 cm depth of air without breaking it into compartments. So the air will circulate really slowly, and you can have a very good insulation quality just using air. Okay, and we actually created these series of what is not called vacuum, but different zone to create a chimney effect for the curtain wall. And of course, it has different environmental factor. UV degradation is a big problem. How do we reinforce that? Using most least toxic methods to reinforce that, including the recycling system, how that integrated with LEDs. Of course, if there's a video, if you play that, all this moves. Does it work? Let me see. If you just press it, like so, we integrated with LEDs, so making trash quite sexy, and we actually have to design. You can see why we designed the brick still like a bottle is so we can communicate, and using the same construction methods as the bottle, and utilizing the best part of the bottle, and then to communicate the idea that it's coming from the bottle to the building. You technically can take out the cap, right? We did the preform. Technically, you can take out a cap. You can use glue to laminate, but instead we did not because we wanted to be all separated and recycle. Okay, so quickly, I think this is one of our coolest thing that we have out of all the media is that we're part of that article that talks. This article, one of it is actually talk about our innovation with the new things that we're doing, which is going into organic. We go into organic bioethanol, recycle from food waste. Okay, that's why we are working with the Taipei city government. We are taking all the food waste and we are taking that. We are making a little pilot plant. So if you come to Taiwan in August, you will see this pilot plant that we take cities' food waste and we turn that into ethanol for polymer. I think that's recycled PET. I think that's a very interesting solution that we are proposing. And another is what Chris is completely responsible for is the fiber reinforcement. I think that's one of the new things that we did that can really hit well with the consumers and the designers. Basically, we reinforce it with agricultural waste, including rice husk, wheat husk, and the stem, right? And then that has a lot of silicon dioxide in it, which reinforces the plastic, make it quite strong. And of course okay. So one other thing we do on a daily basis is that I'm still teaching as a professor in Cornell. We do, so we start making students do bridges made from trash. and we start making them sit on their own bridges that only weighs like 80 grams. Okay, so you can imagine all this material, it's just missing some repackaging. I think the first thing, in order for any material to be sexy, it has to be strong, right? Just like you wouldn't imagine you go to a club, you see a scrawny guy, and you're like, dude, that guy's so sexy. This guy has to have high performance. High performance in terms of, we work with Nike, later you will see, it's all about performance. Without high performance in the automobile industry, like without high performance in airplanes, no one's going to think this material is going to be very sexy. So the first thing is the course is called Sexy Trash. So the first thing to make your trash sexy is make it high performance. So structurally strong, without glue too. So they can only use two things: a board, recycle extruded board from polypropylene, okay, and then polypropylene, so extra soft, okay. And then you have to reinforce it only with cable, without having cable. Also, just recycle yarn at, I think it's 36 denier, which is really, really thin. So you got to use these baby thin material to create a bridge. And of course, there's a recycling problem. I think a lot of us, we mentioned that earlier about all the interesting thing about using virgin being more and more, and then recycling is doing less and less. Of course, all the slides got really messed up. So another thing, I think one of how we started 10 years ago, I think one of the thing is, I don't know if my movie analogy, you guys watch Zhou Xingchi, Stephen Chow. He's a very famous comedians in this part of the world. Okay, he talks about material innovation in his movies, and he talks about how material innovations can become a business, can become a great marketing products. And that's when the reporter actually talked to him. He made this fish ball, like actually beef ball, and then like the reporter asked him, why is this beef ball such a success? And he says three things, and that's the exact same model of why we're in this industry. One, the first thing is it has to be tasty. It means it has to be functional, basic, okay? The second thing is it has to be new and bold, that shock people. So it has to have new material properties. It has to have new material characteristics that let people seize the possibility. But the third, I did not really get it until like the last 2 years. That's why I keep using this slide. It's called playfulness, okay? Without something being fun, even though everything has to be functional, all that stuff, without something being fun, just like, why car company does concept cars? It's because it's fun. People like that thing, right? Like that thing, like that performance. Without that, our engineer in the office, like Johan, Chris, all are this young mind who has super huge amount of education. We're not going to feel comfortable working in a company that does not value creativity. Okay, so I think that playfulness is one of a crucial factor in some of our very aggressive innovations. And I think I also disagree with a lot of a marketing company about the greenwashing. So here's why I think I can also quickly explain why greenwashing is, because greenwashing is done by the wrong people. That's why it's called greenwashing. Because, for example, if you're selling a piece of candy, okay, you do greenwashing, you're just washing on the outside. You just know, recycled material, great. Low carbon footprint, great. But that is just on the outer packaging of a candy. In reality, in order for you to really affect the system, you have to change the sugar, actually. So like what Mike, MBA Palmer, is doing is changing the sugar content. He's making a substitute to sugar, all right? But from substitute to sugar, there's still a long way before you get to customer, before you see the packaging, right? So if you just have a communicator, like let's say Saatchi and Saatchi came in and says, let me package your product for you. None of them knows about material. None of them know about engineering. None of them knows about how to apply, to jump different things. They just have good ideas. They have these taglines. They have that 0% virgin part. But what's the inside? It's missing that. So what we are filling the gap is the engineering part, finding new application and engineering and designing. So before we get to design, we actually had to engineer and find a new solution for these materials. And And this is where I get into a lot of people get really confused with what we do as a company because one of our goal as a whole, we want to convince two type of people, not the consumer, surprisingly. I think consumer get it because they throw away bottles, they know it's bad. They know it's bad. You don't have any consumer. We are convinced two type of people. Both type has huge amount of ego, just like myself. Okay, one, designer, huge ego, huge ego. Okay, designers like think they're the god, yet they don't know any of the physical property of many things. Okay, because they use their visual, they use their eyes to do their thinking. The second is obviously MBA guys. Okay, our company when we went through a round of fundraising and we hired 4 MBA from Ivy Leagues, and it's the worst mistake I have done. Okay, because they only think about how to replicate. They think about selling. They think if you think about selling, it's not that easy. The key is it's not that easy to sell yet. But how do you convince them to believe that what we are doing is valuable? Because they don't get it. They're thinking from the marketing side, oh, you're just doing marketing. They're just doing marketing. Okay. But what about engineering? Oh, you're just doing engineering. So they're not tying that together. And then, so I think that's a key. These are the two people. If you convince the MBA about an idea, that means potentially there is a replicable money-making thing. And then people will follow. I think that's one of money will follow. Another is actually designer. How do we convince them to use our material so that it has to be strong, sexy, textural, etc. And this shows our stream. We're trying to add value to the material that came in. We're not trying to do the material. We're trying to do the material, add value to the material that came in. We don't work with the manufacturing system in between because those guys has more manufacturing expertise in Taiwan, in China than everywhere else, right? They manufacture, just imagine Taiwan manufacture all this crazy fancy products. So they have all the manufacturing techniques already. They actually have 30 years of manufacturing experience. Us as a young engineer go in there and you're telling them, no, you should do it this way. They really just throw you out, okay? So we don't try to mess with that, but we try to work with them on tailoring a certain material to enhance that capability. Then we work with the designer of a brand, okay? So that in general, how we do it, we have 3 ways of doing it. One, we fold it like a very traditional way on a physical millimeter level. And then the other one was do it on the nano level, which is on the nano scale, which is trying to fold the actual compounding using amorphous particles to give that extra gravity, to glue extra, to make it bond together better. The other is mass manufacturability. I think that is also the key. We work with the existing manufacturing system, but recycled material is really hated in the industry for remanufacturing, okay? And that is one of the big hurdle for our industry. Of course, this shows how we add these organic rice husks to reinforce our material, how we get extra strength, etc. This is for the cement. There's a video here. Can you play? We work with Nike to come up with a series of yarn. Can you play the video here? And we work with Jay Chow, one of the directors of Jay Chow's video, okay, on this animation to communicate how we take recycled bottles, infuse with organic rice husk silicon dioxide to create a series of yarn for fabrics and for shoes, for these shoes, Fly Knit, this new 100% knit together shoe with, or maybe next slide, but it's, and how that link with sports. We actually turning that, how that link with muscle, movement. Of course, it has sound too, so. No, it's okay, it's okay. And that video we produce, not Nike, actually. So we produce on behalf for Nike to communicate a certain idea. And one of the things, the idea is very simple. How that we can always relate to all the customers that we have is that we use food and water, like anything you eat, anything you drink, anything you use, iPhones, your computers, we can turn that into materials, okay? But of course, we don't turn that into materials. Like NBA turn that into materials. Other Far Eastern group turn PET into materials. Farmers turn husk into like ashes, actually. Okay, and we take all that, we combine them, we create new materials out of it for designers, for architects. So you can see there's a B2C side, which we never make money from this side. It's just pure communication devices. Then the actual part that drives our secret volume, we have this secret stash of volume. How we can create this demand is from architecture, because there's so much surface area that create enough production runs for us to actually sustain ourselves. Okay, and of course these are some of the brands we work with, and we work with a lot of the brands on the embedded side. So I just want to quickly give you the Flyknit Pavilion we recently did in Beijing. I started with my sketch and a lot of companies' idea about how the lightest shoes ever launched with Nike. And first of all, this material is not made from recycled material yet. It's only 100% virgin, mechanically stitched together, knit together. Okay, so at least you can take the upper and you can recycle it just like any recycled bottle. Okay, so that's the first step. Of course, the next step you can imagine is taking the recycling into that account. And we created a space using reuse all gas drum in Beijing. And we take that gas drum, we turn that into a giant knit pavilion, all made from recycled PET, basically all the same material from the shoe. And it moves. As people go in there, as you exercise on these floors, step on these floors, the whole ceilings is moving. So the sports activity is normally specified by two things, tension and compression structurally, right? So you turn that, you combine that, that turns into torque. So we are basically taking all the tensile elements into recycled PET yarn and compression element also into polybrick, all without glue. And of course, influencing the strong and sexies like LeBron James. I think that's very important for the development of this industry. And we tamper with lots of random stuff, and we have lots of fail examples. Why all of the MBA people in the office hates me? It's because we tamper in food packaging with recycled material. It has a really bad result from it. We lost quite a lot of money from this packaging solution. We made transportation. We made a boat, sail a little yacht that we sail around in Taipei and Taiwan, and all made from recycled material, from the decking all the way to the cloth for the sail, and all the way to the flotation. It also has solar panel CIGS embedded, so you know it's buildings. Of course, we go to Germany because one of guy in Germany says that our thing is not self-structuring. It's not structural. It's actually not a structure. It's a decoration. So we just built this thing. We intentionally split the legs into two, just like imagine someone standing barely touching, and we have the mayor, all the Green Party people like hung on it, like you know, just like look, it's structural. Okay, it's all air, but structural. Okay. Integrating with LEDs, of course, linking that with iPhone, office light, panels with light, furnitures, storm shield system. By the way, these are all built, right? So, and this is the Hong Kong's Green Building Council. We work with the architect, and these are our materials for all the dividers in the conference area. Hotels in luxury apartments. All this is our products, our materials. Celebrities' home because they're quite sexy, so they obviously will have sexy friends. And that's we also did the Design Expo Pavilion for Taipei, also all using the same material. We are exhibited currently where, Johan? It's in. It was in Moxie's, and now it's Montpellier, yeah, in south of France. And it's talking about recycling and structural system. We are working with Xinhua Shuju in China, the biggest bookstore in China. There's normally, if you know Xinhua, a bookstore is a very not so pretty type of bookstore. So we try to upgrade it with recycled material and a sort of a more progressive. These are the green building project. This is our first green building project in China, Chengdu, Tianfu Guangchang, using BIPV system and with recycled canopies, actually, initially, just trying to use recycled material for everything we do. Of course, it didn't work out so well. I had to turn this picture into black and white photos because at the end, the client chose a crazy color, and I'm just so ashamed that, it's like I can't look at it. This is a building that's currently being built. It's actually going to be documented by National Geographic on the mega structure for another one. It's called, again, very much related to what we are talking today, called urban mining, above surface mining, etc., right? But this is one of the world's biggest e-waste recycling factory, which we are building. One of the most interesting thing is in the eco park in Taiwan, you cannot have excess water coming out. It has to be contained. You will not be able to put in new a lot of what do you call that? New water source into the production system. You actually you have to directly exit the water into the typical stream without. So that's mean the plant by itself has to have a water filtration system, has to have all that self-contained. Okay, so coming in and coming out has to be almost zero. Okay, and of course, they change it into solid state. That's why. Okay, some part can be shipped out, but still, what I'm saying is, you can see this material here on the outer canopy is all recycled PC, okay, and laminated, and also the fenestration system is made from e-waste. Basically, we add in the glass fiber. So you can see the plant, and this is on the 5th floor of the plant. It's almost going to be finished end of September this year. Cemetery, I think we're dealing with end of life also in the human scale. So we are recycling. This is actually eco cemetery that we're also building in Taiwan. It's actually for us to get recycled turn into energy, right? And then we take the ashes and we plant it back into it's a tree burial cemetery. And exhibition center in Malaysia. This is a housing project next to a golf course in Shanghai. This is exactly what we call a movie theater made from a pirated DVD, I would say, okay, in China. And that's very interesting. I think it's like the whole story kind of tied together. So this is a giant 4D entertainment center in Shanghai. It's actually being built. This is a housing project in Taiwan, a single home, actually a very wealthy family that decided to use this Carlo Scarpa, or if you guys are Italian, you guys know this famous architect in Italy, that we try to use that same style by using recycled material. So, all right, and then we also do some pro bono stuff, which we did for the disaster relief housing for schools after the major hurricane in Taiwan. So these are, that's actually built, but of course at the end it's not as simple as this. It's much more complicated. They added all these flowers and vertical gardens. And this is a secret project that we're doing, so hopefully you will see this crazy recycle pavilion is going to show up in Taipei, pop-up pavilion. It's going to show up in Taipei. And we also advise on some of real estate developments on how to use recycled material and embed it into the actual usage, and for the designer to force them to use our material. So that's about it. And if you guys have any questions later, we can definitely ask in public, and of course with Johan and Chris while we are interfacing the whole day. I think it would be okay. Yeah, it would be great that throughout the day you can interface with our material guy, with our sustainability guy, and with me. I think it will be a lot of fun. I think we are all selling to the same. We're in the same choir, so.
We have time for a question.
Okay. Yeah.
Anyone have a question? Anyone have a question for Art?
No questions? Oh, you were very clear.
No brilliant ideas for him to create an airplane or something?
Yeah. Like our dream is to create an airplane, but Boeing is way better at it. So, by the way, the boat we created sank. One of the reasons we infuse it with fiber and it's like WPC type of stuff. It looks like it doesn't take up water, but after 3 days it still gets saturated, and then start leaking, and the whole start. I mean, it's a lot.
Well, that's a oh.
Just a quick question. So what happens to the great designs once they've finished their life?
Okay. So the idea is all the design has to be disassembled. So everything we do, we try not to use glue. So even the shelf here, everything is not glue. So you can be taken apart. So all materials are designed in their just original state. For aluminum, it's aluminum. Wood is wood. Plastic is plastic. So they can be disassembled. So one of the biggest trick is glue solves so much problems, so much. And then to tell you the truth, we are faced with that dilemma all the time, especially in engineering, because 3M designed their products so well. You just just like little double-sided tape, boom, done, and then everything resolved. But we are going all the way around trying to do all this and make it. Sometimes it doesn't look so good, and then it's quite a tough choice we face with that problem. But I think in order to keep it our mission, I think we have to continue to push for that, for other designers to really appreciate the aesthetics. It's a different type of aesthetics because you're going to get a little bit bulkier.
Thank you. I have a question about the limitations of using 100% virgin material. So you said actually the biggest challenges are your MBAs and your designers. But is there any kind of technical limitation that you found that using only recycled material just technically that just can't do?
No, right now you have two questions: 100% virgin, 100% recycled material.
So,
First,
sorry, 100% non-virgin.
Okay,
Yeah.
100% non-virgin. One of the problems, if you get to a certain engineering type of material, the ones you can start using in a very attractive way, it gets to be also just as expensive, if not more. Okay, so MBA-wise, if you want to do high-end products, especially that's what we need right now, I think, it's going to be cost slightly more. So how do you convince people to switch unless it has a huge amount of marketing, communication aspect that you can communicate as a brand, right? The second, obviously, for the designer, the biggest constraint is that 100% recycled polymer, you go to a manufacturer, they just don't want to use it, do not want to. So what we call, we make so much molding, okay? If you do try to do an undercut, do you know what an undercut, like a mold, okay, undercut? If you do an undercut, recycled material what normally will come off, okay? You cannot either, when you take it out, it's going to have a little bit extra force. It's not going to have enough kind of stick together as much, so you're going to have these imperfections. So if a designer care about that little undercut, which you shouldn't design an undercut anyways, I just think that's just a stupid design. But you shouldn't design undercut anyways. But if you're going to do an undercut for your design and you're using recycled material, it's not going to come out perfect. And you're going to hate it, right? So you're like, no, forget it. Because of my ego, I need to do this. And then that's a problem. So that's one of the biggest two hurdles is remanufacturing and also the price.
All right, thanks a lot for that. Joel, do you have one quick one?
Those wonderful slanted rooftop facing the sun, possibly.
Yeah, exactly.
I presume that your material can act as a substrate for solar paneling.
Yeah.
You didn't mention that yet.
Oh yeah, it's true. Like a lot of our roof is designed to optimize for solar gain. Sometimes you want to shed away from solar. Sometimes you want to optimize for solar gain. But that's mean when you optimize for solar gain, one of the biggest problems is you have huge amount of insulation underneath it. So that's when we have to create a separate layer for solar gain. However, yes, it become a substrate. These recycled material become a substrate for solar PV. But I think ideally, we've been using solar PV for a long time, and we are getting quite frustrated by the technology. I'm sure a lot of people are. Part of the reason is actually not the PV problem, it's actually the battery problem and the actual usage problem. So we actually prefer these days, I would say, the thermosolar tube. Okay, so we actually want the heat. We actually want to have the heat gain. And of course, you want to insulate that heat gain from the interior. So then we use recycled material again, either through air or foam boards with recycled material.
Great, let's give Art a big hand. That was a very great talk, and I'm sure that inspired